Okay, I think we'll get going. It's 11 o'clock by my watch. So welcome to the Relialytics third webinar, using equipment data to extend component life. My name's Osman Bohemia from Relialytics, and I'm joined by Angus Lay and Matt McLeod as your panelists. For those who haven't attended one of our webinars, they're 30 minutes, we get to the point, and we allow plenty of time for questions. And also afterwards, we can answer any questions that we don't get to and continue the conversation a little bit later. So the topic we've chosen this webinar, Extending Component Life, it's a 30-minute webinar, which really should take about 30 hours to really get to the point of what value you get from extending component life and also what's required. So 30 minutes isn't enough, but we're going to give you an idea of where to start and just some ideas to think about. And we'll leave you with some steps to go ahead with after this webinar to see if your site is ready to put in a program to extend component life by using your equipment data and condition monitoring. Happy for anyone to jump in with any questions as we go. Use the Q&A button and we'll get to your questions. And as I said, if we don't, we'll answer them afterwards. Matt McLeod and Angus Lay have good experience in condition monitoring and equipment. Matt McLeod is a mechanical engineer. He's worked as a statutory engineer in coal mining. He's worked with Fixed Plant, and he's also had 12 years with Caterpillar. Angus Lay is a marine engineer, spent 16 years in that industry, but he's also worked for ALS laboratories. He spent 6 years there, and more recently at Peabody for 5 years as their asset health manager. So the two gentlemen have very good experience, and hopefully we'll be able to answer any of your questions that you have. So I'll hand over to Angus and we'll get started on the webinar.
Thanks, guys. So, I mean, obviously with, extending component lives, so a couple of questions you sort of, need to ask is, why are you sort of pushing the line? So one is to manage costs, and that can be due to obviously downturns, budget pressures, large fleets of components with PCRs that are due, around approximately the same time, and OEMs no longer holding the sort of levels of stock that they did previously. So potentially target life might be 24,000, but on that fleet you could eventually be changing some of those components out 6 or 12 months after they achieve that target. So there's obviously those risks that you want to manage, all those reasons to push those components so you can actually change them out of the planned state. You've also, probably the main reason is the sort of to remove a component from the life cycle costing, and that's where there are huge sort of financial incentives and cost benefits to the business, and that not just only components, potentially even subcomponents. For example of that, by removing a set of injectors from a specific engine. I'll give you sort of broad details, but a set of injectors was worth around about $70,000, and the OEM interval was 8,000 hours. Now, by pushing those injectors out to 12,000 hours, it meant we effectively removing a set of injectors for the life of that, from the fleet, from that life cycle of that particular engine. And on a fleet of 10 trucks, it quickly adds up to a $700,000 savings. So that's just in pushing a set of injectors on each engine. But when you come to removing potentially an engine from the life cycle of that particular machine or from the life of mine, the savings are considerably higher, because now we're talking anywhere from $400,000 to $800,000 for an engine, times the number of trucks or machines that you've got that you're looking to do that life cycle extension on. So quite quickly you can add up into the tens of millions of dollars in potential savings in costs. Okay, but things you need to consider. Have you identified the risks in pushing component lives? By extending component life, it has the potential to introduce new failure modes that previously weren't an issue or didn't sort of weren't apparent. One thing is critical. You need to understand your component health. When you remove a component for PCR and it goes off for rebuild, and on a component that's made for life, you need to get those teardown reports from the OEM to understand that condition to determine whether or not you can actually safely push that component further. If it is received in a condition where there's obviously critical issues, then potentially you're already pushing as far as you can. But if there's still life left in that component, then there's the sort of the proof or the evidence or the data to indicate that you can actually safely push that component. And again, if you've got a component that has failed in service or didn't reach target life, critical again to get those teardown reports done to understand what caused that failure, so you can put steps in place to mitigate those risks. Otherwise, you're just going to continue to potentially repeat that issue. And again, you need the systems and the processes in place to manage these systems, these issues, whether that be sort of onboard telemetry data, oil sampling programs, analysis, and dedicated people that are reviewing and driving actions from those issues that are identified. The other thing you need to consider is obviously subcomponents that would have previously made full life on that particular engine or whatever it might be. Can they also be now pushed to the new target, or do you need to think about a potential midlife strategy that brings those components in to change them earlier? Because what can happen is that it's rare that the large component fails on its own. It's normally a component that's attached to that has failed, that has taken the engine out. So you need to really sort of quickly identify where those risks are and identify components that you want to replace pre-failure or after failure. So, for instance, a fuel pump, a high-pressure fuel pump, if that was to fail in service, there's a good chance that that's going to damage the timing gears and potentially destroy the engine. So that would be a component that you would look to do on a midlife strategy to remove it before it can actually fail, because you don't want that to fail in service. But for instance, something like a turbo, where if it fails, there's minimal risk that it's actually going to cause any consequential damage. Those you would potentially look to manage as an after fail or strategy, because they're a lower risk. So all these things need to be taken into consideration before you look to extend a component life, to understand all those potential risks that you're now being exposed to, and have the process in place to mitigate those risks.
Thanks, Angus. I just wanted to highlight, I guess, the size of the prize for some of this activity in pushing components. And this is a current project we're working on with the site. And what we aim to do with this modelling was just to understand what's the order of magnitude of any savings that they might see if they were to aggressively target component extensions. So that dark blue line at the top is the baseline condition. And the other three traces are just various options in terms of component strategies. And in this particular case, the site's got a 9-figure improvement opportunity range. So it's very significant for this site. And the main prize comes from, as Angus said, removing one major component exchange in the life of this truck fleet. So, that's multiple millions of dollars per machine, and multiply that by the number of trucks, that's quite quickly adds up. So even these worst case scenarios, or the lowest returns on investment, is still multiple millions of dollars savings over the life of this particular trucks. But pushing components this aggressively really requires the best processes and systems to support the activities of your team on site. So there's some things we can control, and there's some things we can't control. So the things that are out of our control are really the design of that piece of equipment, and the OEM's designed for expected operational loads. What they expect and what happens in reality might not be the same thing. They aim to validate those predictions with measurements and field testing, but field testing is limited. You can't test for every failure mode. You don't have enough time or test machines to do that. So we expect our OEMs to have a process to be able to collect field feedback and then improve that design so that subsequent versions of that machine or those parts realise that life expectancy that we're looking for. We also can't control what happens in manufacturing and anything that happens during assembly of machines in the factory, but generally those issues appear relatively quickly and not something that happens at 20 or 30,000 hours. So warranty is the process that covers those defects in materials or workmanship in manufacturing. And likewise, we don't have an opportunity to affect the quality of particular parts that are used in the machines. But again, parts quality issue would generally appear relatively quickly, and that's what warranty is also there for. And then, of course, there's a whole lot of random events that are completely outside of our control. But what we can control are maintenance and operation. So in terms of maintenance, are we using the right lube for that application? Can we keep the oil clean? Can we keep the oil at the correct operating temperature? And do we have condition monitoring routines that will help us detect any imminent failures that might be occurring within that component? And to complement that, in terms of operations, are we controlling our operations and are we operating within, say, an OEM's guideline for payload? So further to some of the comments that Angus made, some of the questions you might want to ask yourself and for your site is, why do you want to extend component life? Have you got a payback that you can see for your operation, whether it be at a component level, at a site level, at a life cycle cost for the machine level? Can you manage the risk of failures, as Angus said? And what can you do to better understand the component condition in your fleet? So in order to understand your component condition better, you really want to be extracting full value from your condition monitoring data. And we need to take action with the data to give our components the best chance of survival for the longest time possible. But responding to alarms and alerts often means that some of the damage has already been done and you've already degraded some of that component potential. So I just wanted to quickly give you an overview of how we do it at Relialytics and why we think it's better. So here we've built a platform called ECS, which is the Equipment Condition Supervisor, and it's intended to increase the effectiveness of your analysts and reliability engineers. So here's a simple schematic of how it works. I'm just going to explain the steps in a little bit more detail. So firstly, we've all got a lot of condition monitoring data. Generally, they're all in separate databases. So your oil sample results might be in one particular database. Your machine electronic data might be in another database. And you've probably got spreadsheets and service sheets with handwritten measurements that are stored somewhere else as well. What we aim to do is connect electronic databases to our Azure processing platform. And over the top of that data that's housed in that platform, we'll run our own rules and triggers over the top of your data. So we've got lots of them and we do it instantaneously. And those rules and site-specific triggers are all generated from your historical data. So we don't use generic limits for oil samples or from machine electronic data. We look at history on machines and we very carefully calculate site-specific limits with the intent of giving you the earliest possible notification of anything that's outside the ordinary within those components. We don't give generic high-level recommendations. We generate specific text for specific conditions that's suitable for the workshop to diagnose and address that particular problem that we've identified. After that, we only send the exception reports to your analysts. We don't send everything. We don't send all the, hey, you don't need to do anything with these samples. None of that is visible to your analysts. It's only those activities that need to be actioned. All that's presented to your analysts on a web interface, simple dashboard where those notifications are displayed, and your analyst can very quickly agree or disagree with the recommendations that we've put forward So he can quickly say, yes, that's a good recommendation, let's do something with it, or he can flag to the system and back to us that, hey, that outcome is not what we agreed to or what we think is appropriate in this particular case. Once he's done that, those specific recommendations can generate work orders in your CMMS or straight into a flat file if you want to import them somewhere else. Back to Angus.
Okay, thanks, Matt. So yeah, I mean, how does this help the analysts or the reliability engineers or the supervisors on site that are having to review these large, volumes of data? Well, one, in particular is, as Matt alluded to, our limits are set based off the historical data from your site, whereas the lab alerts are generally based on a large community. They are set at a higher limit, and this is mainly due to, obviously different operations having different operating conditions, maintenance strategies, even the lubricants and the skill sets as well, able to identify these issues. So the lab do tend to err on the higher side, but what that means is at that point, you're already starting to take potential life off that component. Once you've worn through all the iron, it's time to change component out. So the value is in getting it the early onset to improve that condition. And every piece of data that comes through ECS is analysed, and the decisions that are made by the guys that are reviewing this data is captured, and that's mainly for the next person that comes in. That for instance, if the issue is still present on the next sample, or that particular machine alarm hasn't been rectified after the initial recommendations were actioned, that person can see what was recommended and then make a different decision to rectify that problem. Essentially, what the system does, it breaks that traditional condition monitoring loop where an oil sample comes in, with dirt ingress, we go out, we change the oil. The next sample comes in, potentially someone else on swing, they go out, they change the oil again. Next sample comes in, we've still got dirt. You're not actually getting to the root cause of the problem. We're just band-aiding it. So the system allows the user to easily see that, hey, look, we've with the time and condition reports, we've had this issue for 3 consecutive samples. We've not rectified it. All we've really done is just change the oil. Hey guys, have we had a good look at this to identify where the dirt is coming in? And let's get on top and fix this issue before it results in component damage. And again, ECS identifies the real issues from the noise, and with a click of a button, you can push a notification directly through to SAP. So it sort of streamlines that potentially, that laborious task where the reliability engineer and supervisor has to, understand that oil report, determine what they need to do, and then go into SAP or their CMMS system and generate that notification for it then to be executed. ECS simplifies that process. Basically, it will provide the recommendation, the understanding of what's actually occurred, and it will generate that notification directly in the CMMS. So it just streamlines the whole process, which ensures that these things actually get actioned, and there's a record of what action was taken in ECS for the next person if that problem hasn't been resolved. As new failure modes are identified, ECS has the ability to learn, and we can catch those as a new failure mode, and it never forgets. So it's not reliant on, 6 months ago we had an engine fail and it was this particular problem. The system never forgets that failure mode once it's been identified. So it's there in 12 months, 18 months time, and as soon as it sees that scenario, it will pick up and identify and flag that issue through to the dashboard for the supervisor or reliability engineer to action and convert to a notification. Okay, how does this extend, help extend component life? Well, one, obviously the analysts and reliability engineers are better informed about their component condition or their fleet health. And, realistically, component life is a direct result of life experience. If you're currently managing your fleet condition on your CNX samples or your, red engine alarms, then you're already doing damage to that component. So the earlier we can identify these issues through ECS and put them into the workflow process, so into a notification, get planned and executed, the less damage it's going to occur. And because we've set the system has set the sensitivity at the early onset, it gives you the best possible chance to actually action this in a planned state rather than waiting for a breakdown where you've got to either pull the machine up or it's already pulled itself up, normally in the most inopportune sort of position under the digger in the middle of a haul road. So ECS gives you the early indication of that issue and simplifies that process to get it actioned. The other thing that you with the site-specific alarms early notification, as we just mentioned, it gives you that early onset indication to rectify, immediate work order generation. And the other thing is we only report on these sections. So a lot of the reason why a lot of sites only focus on the CNX samples, because there was just so much noise in the B samples where there are issues there which are not going to cause component damage. But the reliability engineer or supervisor needs to filter through all that noise to identify what is the issue. That only gets worse when you start talking about machine health data, because you could potentially have a noisy sensor that could fire once or twice a day. You're not going to pull the truck up to fix that, but it's just that over a month could report 300 or 400 times. So it's about identifying what are the critical ones that will cause damage and making sure that they're the ones that get the focus to be fixed.
Okay, thanks, Angus. So just to finish off, we would like to just give some next steps for you to work on. The first, and these are probably in order that need to be done. And first of all, and first and foremost is it going to be beneficial to your site? There are risks involved, and it needs some thorough research to see if this is actually going to be of benefit. Is it going to reduce your costs? Are there greater efficiencies? And if you're happy with the risks and you believe it's going to assist your site, then you move to the next step to work out which is the equipment that's best suited. We wouldn't recommend going and doing a whole fleet, all of your equipment in one go. It's a matter of selecting the right equipment to use. Where do you have good condition monitoring data? What already has good maintenance practices that you can actually select the equipment that will extend component lives. And then the last one, which is really important, is identifying the roadblocks. So there are a number of roadblocks that will be there, such as your site culture, your company culture, planning capabilities. There'll be things like the head office programs and projects, all of the risks. So it's really identifying the roadblocks. And these are the steps we're recommending that you take before you even move into doing any component life extension projects. So we'll move on to questions. We've got a few minutes. We've actually got quite a few good questions that have come through. And I just want to make a point that if we don't get through all of them in our 30 minutes, we'll answer the questions and we'll post them out to you at a later date. So we'll get to all of them eventually. A question that came through overnight, it's a question around extending component life by supplying clean oil. One, is it okay to set the cleanliness level for new oil lubricant delivered on site? Angus or Matt, do you want to take that one?
Yeah, look, I could probably field that one, Matt. Yeah, absolutely critical to understand the cleanliness of the oil going into your equipment. If you're starting off with contaminated oil, then you're basically fighting an uphill battle. So absolutely specify limits for cleanliness. My only sort of recommendation on that, and this is coming from my lab background, that laser particle count is not probably the best method to do that by. Typically a patch method, because what can happen in obviously new oil, you've got oil additives that are still they haven't actually dissolved, which can actually register higher than typical particle counts for the new oil, which would be higher than what you would consider being a clean oil for that particular compartment type. So definitely patch test is a better way, because the analyst that is reviewing that patch will take that into consideration and give you a much more realistic picture of that oil cleanliness or oil cleanliness level. So yes, absolutely critical, but patch test is the method you would need to specify with the lab to do that for to get an accurate result.
Okay, another one that's come through is what process do you have to collate data from paper, manual-based systems, e.g. work orders from ERP?
Yeah, look, manual paperwork is always going to be a difficult one. I would suggest that yeah, any feedback that is recorded on work orders, there are programs now that you can use that will scan and actually upload that directly back to your CMS system or as a scanned copy. Yeah, that would be the way moving forward if you're not already doing that. At least then you've got it in the system, it's captured, and if it can be interrogated through other systems. So yeah, handwritten notes, fantastic feedback. The guys are putting on the work orders. You need to have a process to capture that and get it into your CMS system against that work order. Specifically when you're doing defect elimination, that information is critical to understand whether or not what was recommended has fixed the problem, or if it hasn't, what we need to do next to actually rectify that problem.
Another good one here, and I'm not doing them in order. I'm taking bits from everyone, but as I said, I will make sure all of the questions are answered and they're sent out to this group. So what can you do to ensure the guys actually execute the recommendations that will extend component life correctly?
Look, there's this is something that I struggled with at Peabody. Obviously, we were pushing components well past manufactured OEM, and we had a large asset sort of or condition monitoring program. It really is just educational and setting that expectation. For years, the workshop guys were sort of writing feedback on work orders, but nobody ever did anything with it. So it's about changing those perceptions again and getting that feedback. Once you start, you find that the guys are quite happy to provide it, but they want to know that someone's actually using that information. And that's where we were very successful. We were continually driving that feedback. So if we put through an action, we would be looking for the appropriate feedback each time, and we would be chasing the guys on site to provide that. So they very quickly got used to the fact that if they didn't actually put anything back into the CMS system, they would be getting a phone call from us saying, where is it? Or I'd be up on site with the guys, chasing them directly, having those conversations in the workshop with the supervisors and the guys on the floor as well, because that's where the information needs to come from.
Okay, this will probably be the last one. We might get one more in, but what about the system allows us to specifically extend component lives as opposed to managing our current lives? Can we flag components that are being extended?
Yeah, absolutely. I mean, typically what you would do is through the ESIS platform, we'd have a list of senior component or a senior component program, which we would know that have been targeted for extended component lives. And it would have that information in the system, so you could see it quite easily that particular truck or that fleet, that engine is part of that program. So it gets that, that additional level of scrutiny.
Okay, one more, we can get one more in here. Do you model specific equipment and failure modes with recommended strategies?
Yeah, we certainly target the algorithms. Once we've identified a specific failure mode, we will target the algorithms to identify that and look for it. But then we will also, as part of that journey, is then obviously looking at sort of strategies to manage it, so that we're not waiting for that event to happen. Is how do we remove one of the causal factors or more that prevent it from ever happening? So hopefully I answered that correctly.
Yeah. Well, we keep to our promise on the 30 minutes. We didn't get to all of the questions, but we might do another little video to answer the questions at another time. But I'd like to thank you all for participating today, and also invite your questions for this topic, but also please send us any topics that you'd like to hear us talk about. We're really interested to hear what your thoughts are and how we can help. and it makes for a really good topic. So feel free to get in touch with me. My contact details are there. Or if you'd like a demonstration of our ECS, we'd be happy to do an online demonstration and talk further about how we can assist you, not just if you're looking to extend component lives, but if you're looking to for your condition monitoring and actually using the data you're getting from your equipment to turn it into action that makes a difference for reliability. So thank you, Angus. Thank you, Matt, for your expertise once again. And I will, this webinar has been recorded and it will be shared with you by email and available on our website. So feel free to let your colleagues know. And we look forward to seeing you all again at our next webinar, which will be in May. So thank you for your time. Well, as promised, we will answer some of the questions that we didn't get to at the webinar. So I'll hand over to Angus and Matt to take you through the questions that we didn't get to.
Thanks, Oz. So I'll take this first one, and just for the exercise, what is the best way of managing contamination on the service trucks? So I guess before I answer that question, I'd probably be asking another one, and that is, are you sure the contamination is occurring on or around the service trucks? And other programs I've seen might be to start a little testing regime for, I don't know, maybe 3 months, where you start looking at the bulk fluids coming onto the site, look at your bulk storage, look at the transfer systems, you know, from bulk storage to the workshop or bulk storage to the service truck, and actually quantify if there's contamination being introduced into the system somewhere. Let's find out where it is so that we don't waste time and money and resources maybe chasing the wrong thing. So assuming that you have definitely quantified the problem and it is at the service trucks, well, then filtration is one way to do that. But again, I would caution perhaps to make sure that you're running a program that you can find out where that contamination is coming into the system. And that should be something that you potentially have ongoing. Angus, you got anything you want to add to that one?
No, I think you probably, yeah, definitely covered it. The only other sort of areas is really around just good housekeeping. You know, whether, you know, potential source of ingress is obviously the coupling. So, you know, it's always good to do sort of spot checks and just ensure that the service cart operators are aware of the criticality of keeping those Wiggins fittings clean and capped when they're not in use, and not just sort of laying around the bottom of the box with the rest of the fittings with oil and dirt and water and muck floating around, because that obviously your oil might be cleaning your service truck, but are you contaminating when you plug it into the actual vehicle when you're doing the oil change or the top up?
Okay, we'll move on to the next question. And I think, Matt, you're going to do this one?
Yes, one more on the previous slide, Oz.
Right.
Okay, yeah, no, thanks, Oz. You know, the second question we received was, is it okay to install an online filtration system to avoid downtime? Absolutely, yes. You know, a lot of large diggers with, you know, large volumes of hydraulic oil have permanent offline filtration systems fitted to them to obviously remove the contamination that the filtration system on the machine isn't removing, being that they're generally, you know, high flow, high volume filters. They don't necessarily have the micron rating to remove the very fine particulates, which can be obviously of detriment to obviously the systems or components on a hydraulic system, pumps and valve bodies and so on, which can be affected. So absolutely not a problem at all. The only thing to be aware of is that you are now potentially moving the evidence that you would normally detect through, you know, routine oil sampling of potential failures progressing or contamination issues. So once you put those sort of systems on, you need to be very much aware that you now need to check those filters routinely at the services, cut them open, look at them, potentially get filtergram performed by the lab if that's a service they provide, just to understand the contamination that's in there and whether or not is an issue that you need to be managing. But yes, obviously prolonging that life of the oil will avoid downtime and also, you know, quite considerable costs involved. in having to change large volumes of oil, or whether it be a smaller compartment like a wheel motor, which may only be 100 or 100 litres of oil, but the cost of that synthetic oil can be very expensive. So definitely opportunities there to avoid costs and potentially reduce downtime and having to do an oil change on a large hydraulic system as well.
Thanks, Angus. I think the point there is to make sure that you're checking the actual filters.
Absolutely, yeah. They're commonly overlooked, and being that they do such a fantastic job of cleaning the oil, they can hide those potential failures. And you may fail a pump, or a component might fail with little to no warning when you have those systems. So it's always be aware if you add something to a system, you need to understand those risks and potentially change your strategy or your monitoring or your condition monitoring checks to cover those potential risks that you've now introduced.
Okay, move on to the next one.
Okay, so there's a question we got about what about if your machines are already partway through a component life, what sort of benefits can we gain? And I would look at this as a opportunity to develop better intel on your machines and their components. So if you're putting in a process to better understand the component condition and its health, it just gives you options going forward. So, you might find that 6 out of your 10 engines are fine. 2 of them have got, some minor issues, and then 2 of them are on their way out. So it gives you an opportunity to be a bit smarter about how you schedule your resources and your parts and your labor and your components and everything else to get the best result for the business based on what you're seeing. So it's just a chance to get better component information about what's happening right now with these machines.
Okay. On to the next one.
Yeah, look, this question, do you model specific equipment and failure modes with recommended strategies? You look, absolutely. I could probably, speak to a real example of that where we had a specific failure mode on a fleet of equipment, and what we learned through obviously exploring what were the driving factors, we found that it was another component that we needed to change strategies on to actually ensure that in this case it was the engine made the extended life that we were looking to achieve with minimal downtime as well, because the component that obviously was part of the whole system was causing a particular failure mode to occur, but it wasn't a fault of the particular engine. It was actually this other component that was driving that particular failure or failure mode. So we came up with a strategy to obviously manage that component, which then prevented the actual failure mode from occurring on the engine or reduced the likelihood of it happening.
Thanks for that. We've covered off your questions that you had. If there's anything specific that you would like to know about these questions, or you need any clarifications, feel free to contact me and we can explore them a little bit further. But thanks for your time.